We explored schematics. Now we also have builders. What are builders? Schematics basically are the tools you run to add something to your project, be that a third-party library or with generate a new component, or maybe also just an update. With builders, you can, build your application for different environments. There are some built-in builders, ng-build, ng-test, ng-lint. These basically all execute your code, compile your code, analyze your code, and then, for example, optimize it for production, run tests on it, or simply tell you how good your code quality is, so you perform certain build steps there. There also is another builder, and that is ng-deploy. This takes it to the next level. It will also build your project for production, but then also already go ahead and deploy it to a certain host. Of course, only some hosts are supported there. It's basically like with ng-add. There needs to be a third-party package or tool which supports ng-deploy so that you can deploy to a host. These are automation commands which you also can customize either by writing your own builder or deployment builder, which is pretty advanced, or by hooking into the configuration and adjusting those builders. Now let's take a closer look. Now, as always, the official documentation is a good place to go, and there you will see under deployment you can learn more about deployment and also about ng-deploy. Here under automatic deployment with the CLI, you can learn more about that. And here you also see the currently supported packages or services which support the ng-deploy command. I'll come back to that. So this is something you can look into. And of course, something we already had a look at in AngularJSON, you can configure some of these builders like the ng-build command. Now, we had a look at ng-build and ng-test throughout this course. We saw ng-lint earlier here, and I talked about this configuration, so that's something we covered. Let's focus on ng-deploy therefore. As mentioned, you can either, of course, deploy manually, as we did it in the deployment section, or you utilize the CLI if you plan on using one of these services that supports the ng-deploy command. And here I want to use Angular Fire, which in the end simply uses Firebase under the hood. Angular Fire is a package that makes working with Firebase way easier, not just when it comes to deployment, but also when it comes to interacting with the database and so on. But we didn't use it in this course because it's not a Firebase course. I only used Firebase as a dummy backend. Still, I want to show you how this ng-deploy command could work. So first of all, we need to add Angular Fire to our project. Why do we need to add this? Because only after adding this, the deploy command supports Angular Fire. How would it otherwise know that it can use this, right? So we first of all have to ng-add Angular Fire, and just as with Angular Material, this will not just install the package, but also make any adjustments which are required and install any other dependencies it might need. So let's wait for this to finish. Now you'll see as part of me installing this or adding this, I'm asked to select a Firebase project. And indeed here you need a Firebase project. You probably do have one if you followed through this course. If you don't have one, make sure you sign into Firebase. For that you need a Google account. Using Firebase then is free as long as you stay within certain boundaries, which are quite generous. So sign in there and create a new Firebase project. Once you created that, rerun ng-add Angular Fire and choose this command. Now important, if you're getting any errors here, you also might want to install the Firebase tools globally, Firebase-tools on Mac and Linux with a sudo in front of it. And once you did install those tools, run Firebase login to log into your Firebase account, and thereafter try ng-add Angular Fire. Now with that, this will add a couple of configuration files here, some Firebase configuration files. And now the neat thing is we can simply run ng-deploy now, and it should automatically pick up Angular Fire as a deployment option. You see it now compiles the code because it runs the entire build process in production mode. What we normally would do manually, it does this here as well. But then it will not stop thereafter. Instead, it will take the build assets, the build files, and ship them onto a server. So let's wait for this to finish here. You see it finished building this, we can ignore the warning, and now it's uploading the files to Firebase, to this Firebase project. And once it finished, it also generated all the hosting configuration files here. Once it finished, we get a URL here, which we can enter into the browser, and there we see our simple Angular application. Now you can then administer this application both with this configuration file, the Firebase JSON file, and you can always redeploy it by running ng deploy again. Or of course also from inside your Firebase console, and there you could also connect a different domain with it if you wanted to. So now that we talked about deployment, let me come back to the browsers list. I mentioned that this is important for telling Angular which browsers you want to support, and this of course is related to deployment. Angular will take the information here to auto-prefix your CSS code correctly, but also so that it knows which polyfills to load and which different versions of bundles it should generate. Now what do I mean by that? Angular has a built-in feature called differential loading. Now, we have our Angular app and we're hosting this, let's say on Firebase or AWS S3 or any other hosting provider, no matter if we used ng deploy or not. We're hosting it somewhere. And now our app hopefully gets visited by users. We might have user A who has a modern browser and user B who has a legacy, so an older browser. Now the thing is, user A with a modern browser, let's say the latest version of Chrome or Firefox, needs no or less polyfills. All the features we use will work there just fine, and therefore we could ship a smaller code bundle to the user, because our code doesn't have to be compiled down to super old versions of JavaScript, and we might not need any or all polyfills, so these packages which enable certain features in a browser. User B, on the other hand, needs a version which is compiled down to way older code, and he or she needs all or at least more polyfills added, so a bigger bundle needs to be shipped. It is what it is. The problem is, of course, we can always ship a bigger bundle so that we support both B and A. If we always ship the most optimized and smallest bundle possible, we ignore user B. There, this just won't run. With differential loading, we do both. The Angular CLI actually produces multiple versions of your app when it builds it for production, you could say. And it produces a small code file, which runs first when a user visits your page to identify which browser this user is using. And then this small initial code file determines which bundle gets served to the user. So with differential loading, a user using a modern browser has to download less code than a user using an older browser. And this gives you the best of both worlds. You support all users, but you make sure that every user just has to download the code it really needs. And this is built into Angular. In our dist folder, we actually see two versions of every file, right? Two main, two polyfills, and two runtime files. And you see the names are different. ES5 basically is the version for the users with the older browsers. ES2015 sounds similar, but it's totally different, uses way more recent JavaScript and therefore also will be smaller. For polyfills, it's the same. Of course, here they both look very cryptic and large, but actually the more modern version will be smaller, and the same for the runtime here. So these are all files that you deploy, and they will be executed automatically. In index.html, indeed, the runtime file executes first, and there it then decides which other files it needs to load. So that's how this works. So this is this differential loading feature which you get out of the box. And you do partly configure it here with the browser list. There, you tell Angular which browsers you want to support, and this tells Angular how it should build and optimize these different bundles. In addition, you have a setting in tsconfig.json where you specify the target JavaScript version you want to compile for. And here it's compiling for modern JavaScript. If you set this to an older one, then you force all users to use this older one. So differential loading really just is a feature to be aware of, not something where you need to do much. You have it out of the box, and this allows you to ship code that works for all users but does not force all users to download all available code. Also, one word about polyfills. You got this polyfills TS file. Now, crucial polyfills like this one are included by default, simply by having this import statement here. Angular will do the rest. If you are using certain features, like let's say animations, and you need to support browsers which don't natively support them, specifically Internet Explorer, Edge, or Safari, then you would need to comment this in and run this npm install command to make sure your Angular animations also work in those browsers. So it always comes down to which browsers you want to support. And you see detailed instructions here inside of this polyfills TS file. So this is how you ensure that your app works for everyone and how you automatically take advantage of this differential loading. Of course, as always, you learn a bit more about this here in the official docs. Under deployment, you can learn more about differential loading and how it works and why it's awesome.